solving linear equations. I know you did a lot of that in Algebra 1 last year. We're going to kind of dust off the cobwebs here and get some things going with solving equations. Make sure we can identify steps and mistakes, and we'll eventually get into some word problems as well. First example, 3/7 x plus 9 equals 15. Hopefully we all remember that our goal here is to get x by itself, get the terms with the x by itself, and then absolutely isolate the x first. So first here, we have plus 9. We're going to leave this term with the 3/7 x alone. First, we have plus 9. We're going to subtract 9 from both sides. That means 9 minus 9, that's going to cancel out. That'll leave us with 3/7 x equals 6. Okay? We did this because subtracting 9 is the inverse of adding 9. Okay? So that's why we did that. Okay? Here, I'm going to turn this. We could do it in one step. I like to do it in two, especially here earlier in the year as we're getting back into the swing of things. I'm going to multiply both sides by 7. What that does is this is 7 over 1. These 7s cancel out. Okay? That ultimately leaves us with 3x is equal to 42. Okay? The 7s cancel. Ooh. The 7s cancel there. Okay? Our last step, we have 3 times x equals 42. Well, the inverse of multiplication is division. So we're going to divide both sides by 3. I get x is equal to 14. Dividing is the inverse of multiplying. Okay. Basic example there, a couple steps using inverse operations to isolate the variable. Next example. We have variables on both sides of this equation. So the first thing I like to do is to get those variables together into one term. I'm going to work with taking the smaller one away from the bigger one. So I'm going to subtract 5x from both sides. Okay, that leaves me the 5x minus 5x. Those are gone. And I'm left with 11 is equal to 7x minus 5x is 2x. And we still have the minus 9. Okay? Collect the variables together. Okay? And subtraction, a negative is the inverse of a positive. Basic sense there. Okay? Now this becomes like our first example. We have 2x minus 9. The inverse of subtracting 9 is adding 9. Negative 9 plus 9 is 0. Those cancel out. That leaves us with just 2x like we want on the right side there. And 11 plus 9 is 20. This is plus 9 is the inverse of minus 9. Okay? And our last step is to divide both sides by 2. I get 10 is equal to x. Okay, and again, division is the inverse of multiplication. And a lot of times that's going to be our last step. Okay. And our last sample to get us back in the swing of things here. Bunch of parentheses, a lot of more terms here, but it's still the same process. Oops. Okay, here we go. First thing we need to do is simplify both sides of the equation as much as possible. Simplify both sides. That means I need to distribute on the left side. I get 12x minus 20 is equal to, I'm going to have to distribute again. Negative 2 times negative x is positive 2x minus 16 minus 6x. We're just going to call that simplify. We're actually going to have one more simplify step. I'm not going to do anything with the left side. 12x minus 20 stays there. We can combine the 2x and the negative 6x. Now they're on the same side. So I'm going to do 2 minus 6, which will give me negative 4x minus 16. Some of you may want to do that as 2 plus negative 6. Same thing, you'll still get negative 4x there. Okay, so that's again a simplify. Okay. Now we're going to try to get the like terms together. Again, I like to work with those variables first. That means I'm going to add 4x to both sides. The reason here, I have a negative 4 and a positive 4. It's going to cancel those out. I get 16x minus 20 is equal to, those are gone, negative 16. So now I have to get this 16x by itself. To do that, I'm going to add 20 to both sides. I get 16x equals 4. And again, 16 times x, the inverse of multiplication is division. I end up getting, I'm going to write it over here, x is equal to 1/4, because 4 over 16 simplifies to 1/4. Now, what was done in each step? How do we get from one line to the next? If we look here, how did I go from here to here? Well, it looks as though this 9a changed to 6a, so it looks like I subtracted 3a from both sides. Okay? Why did I do that? Well, the inverse of the positive, I want to cancel those out and make it 0, is 3 minus 3 will get me 0. But if I do it to the left side of the equation, I again have to do it on the right side, and that's how we end up with 6a. How do we go from 13 equals 6a minus 8 to 21 equals 6a? Well, the 6a doesn't change. It's still there. But we have the minus 8. It's gone. So it looks as though we added 8 to both sides, which we did. We added 8. And again, the inverse, the reason we did it, the inverse of minus 8 is plus 8. And it looks as though we had 6a and we went to a. Typically our last step is division, which is what we did here. 6 divided by 6 gives us 1a. And then 21 over 6 simplifies to 7 over 2. We divided by, what was that, 6. What was done? One more of these. Actually, you know what? We're good on that. We're gonna jump ahead to finding a mistake here. There was a mistake in here somewhere. I did 2 times x, 2 times 3, 2x and 6. That's correct. Negative 3 times negative x is positive 3x. Negative 3 times positive 1 is minus 3. So that's good. I have 3x and 2. They added 5x. They added 3x. When they should have subtracted 3x. Because we need to cancel the 3x, so we need to take it away. We should have subtracted 3x, and that would make this negative x. Okay? And that makes everything wrong from that point going forward.